Hello friends, welcome back to my channel TechnoRays. Before going into the next concepts of natural language processing, please like and subscribe to my channel and click the bell icon to get new video updates. So here we'll discuss about shift reduce parsing. So shift reduce parsing, it's a straightforward procedure working from the ground up. So we can say that a simple kind of bottom-up parser is shift reduce parser. So in common with all bottom-up parsers, shift-reduce parser it also tries to find sequence of words and phrases that correspond to right-hand side of grammar production, and then it will replace them with LHS until the whole sequence is reduced to an S, which is start symbol. So it will always search for string of words and phrases that match to the RHS of the production. And the effort to locate a sequence of words that was just described will continue, or this we can say that this process will be continued until we reach the start symbol. So to put it in another way, we can simply say that shift reduce parser, it begins with the input symbol and works its way towards the start symbol while attempting to build the parse tree. So we saw what is meant by bottom-up parsing. So the same as shift reduce parser is a kind of bottom-up parser, same process will be followed here. So coming to the procedure, here shift reduce parser, it will try to find sequence of words and phrases. So this point we saw just now. So one important thing is shift reduce parser performs two main operations. One is shift and second one is reduce. So it will always push next input word onto stack. So that operation, push operation is called as shift operation. So see here, if the top n items on the stack match n items on the RHS of some production. Say suppose we have production like this, X derives Y. And these are the input elements or substrings present in the given input string. So if these elements, if the top n elements of stack match with the n items on the RHS of some production, then you need to pop these elements and the item which is present towards left hand side, that should be pushed onto this stack. So this replacement, replacing the top n items with this single item present in the LHS, that operation is called as reduce operation, because we are reducing n number of items to single item. So this operation may only be applied to top of the stack. So you can apply this only to the element which is present on top of the stack. So reducing items lower in the stack. So you need to repeat this process. So reducing items lower in the stack must be done before items are pushed onto the stack. So you need to reduce, or you need to replace the top elements on the stack with this LHS before next items are pushed onto the stack. So the parser finishes. So this process will be consumed and will be repeated until all the input is consumed and there is only one item in the stack. What is that item? So at the end, stack contains only root node S. So till then you need to repeat this process. So you'll get better idea of this when we see this with example. So let us take this example. In the initial state, stack is empty. So take empty stack. And input string is the dog saw a man in the park. During one shift operation, push this element the on top of the stack. So the is pushed onto stack. So we did one shift operation now. So after one shift, the is in stack and this is the remaining text. Now you need to replace this element with a tag, POS tag. So for that, assume that we are having production as determiner derives the. So as we already know that the is a determiner, you can assume production like this. Now you need to match this input string, or you need to match this word with RHS of the given production. So if there is a match, then replace that word with LHS of the production. So remove this the from stack and replace that the with determiner. So this is after one reduce operation. Now take the second element from the given string. Second element is dog. So now stack is already having D determiner. Push dog, that is shift operation. After this, we know that dog is a noun. So assume that we are having production as noun derives dog. Now match this element with RHS of the production. So as there is a match, replace that dog with LHS of the production. So LHS of this is noun. So remove this dog from stack and replace that with noun. So after second reduce operation, stack contains determiner noun. So you can see after first reduce, second shift, second reduce. So we did the same. So after one shift, stack contains the, after reduce, stack contains determiner, after shift, stack contains dog, after reduce, it contains noun. So after performing these three operations, stack contains determiner and noun. So we are having determiner and noun. And these are the respective words for these two tags. Okay. So now check whether we can replace these two these two tags with any other phrase. So as we know, NP derives determiner and noun. You can replace or you can pop these elements and replace them with single element. So here you need to replace them with noun phrase. So now stack contains noun phrase. So you can see this first part here. So determiner and noun, they are replaced with noun phrase. Next go to this next element, that is saw. So push saw onto stack. So take stack. Now stack contains NP. We are pushing saw. So as we know, saw is a verb. So if you take the production as we derive saw, there, as there is a match between the input word and the RHS of the production, you can replace that saw with verb. So you can replace this saw with verb. So you can see that here. So stack now contains noun phrase and verb. Next, go to the next element, a. So a is a determiner. And then man. So man is noun. So I'm writing directly. So you first, in place of determiner, first you need to push A. Again, match it with the RHS of the production. And during reduce operation, we need to replace D with, replace A with D. Similarly, first push man onto stack. And after performing reduce, you need to replace that man with noun. So now again, we are having noun and determiner. So you can reduce or replace those two tags with noun phrase. So after performing this operation, so Now we scan the input text till man. So after this, stack contains. So let me erase everything. So after performing this operation or after reading the input string till man, stack contains noun phrase, verb, and noun phrase. So you can see that here in step 4 after recognizing the second NP. So we are having noun phrase, verb, and noun phrase. Now push in on top of stack. So we are pushing in during shift operation. And then, so representation is like this. So remaining words in the input text are the park. So, okay. Now you need to check this. So we already reduced this noun phrase and this determiner in noun phrase to noun phrase, right? Okay. So in should be in as a preposition. So you need to replace this in with P. So remove this in and replace it with P. Next, read next input string, input word, that is the. So you can push the onto stack. So the can be replaced with determiner. So during reduce operation, remove this the and replace that with determiner. Next again, park. So park is noun. I'm writing directly. So first push park onto stack and then replace that with noun. So now stack is having these elements. So as we know, you can replace these two productions. Sorry, these two, this noun and determiner with noun phrase. So let us do that first. So now stack contains noun phrase, verb, noun phrase, preposition, and determiner plus noun, they can be reduced to noun phrase. So you can see this diagram. So determiner and noun, they are reduced to noun phrase. And this P and NP, top two elements, NP and P, they can be reduced to PP, prepositional phrase. So after performing this operation, in next step, stack contains noun phrase, verb, noun phrase. Replace these two elements with prepositional phrase. So we are replacing preposition and noun phrase with prepositional phrase. Next, check whether we can use any phrase in order to replace one or more elements in stack. So this preposition and noun phrase, you can again replace them with noun phrase. So here in the diagram, you can see noun phrase and preposition phrase, they can be replaced with noun phrase. So what are the elements in stack after doing this? So stack contains noun phrase, verb, noun phrase, and these are replaced with preposition phrase. After this step, you can replace this noun preposition phrase and noun phrase with noun phrase. This is step 1 and this is step 2. So after replacement, replacing those two items, we got NP. So now stack is having noun phrase, verb, and noun phrase. And then check whether we can replace these two with anything else. Yes. So verb phrase and noun phrase, they can be replaced with verb phrase according to the rules. So verb phrase, it gives you verb plus any combination of phrases. So you can take that. So noun phrase remains as it is and replace this noun phrase and verb with verb phrase. And finally, replace these two terms. So as we know, S derives NP-VP. You can replace this NP-VP with S. So finally, these two phrases are replaced with yes. So as here in shift reduce parsing, you need to repeat this process until stack contains S. So as we reach this point where stack contains only S, you can stop this process. So you can see these things in this step 6. So noun phrase and verb phrase, they are reduced to S. Now stack contains only S. So this is how we need to use shift reduce parser for parsing the given input string. So this is the process for shift reduce parser.